Hello everyone, and welcome. I'm excited to kick off our session today with an overview of polynomial functions. On this first slide, you'll see the title Unit 1, Polynomial Functions. Over the next few slides, we'll explore what these functions are, how to work with them, and why they matter. So, let's get started and dive into the fascinating world of polynomials. Now, let's take a closer look at the objectives of this unit. By the end of our discussions, you'll be able to clearly define what polynomial functions are, understanding their basic structure and properties. We'll also explore how to perform the 4 fundamental operations: addition, subtraction, multiplication, and division on polynomials, which is essential for manipulating these functions effectively. Additionally, we'll dive into some important theorems related to polynomials. These theorems will help us solve various problems more efficiently and deepen our understanding of their behavior. Another key point is learning how to determine the number of rational and irrational zeros of a polynomial, which is crucial for analyzing solutions and roots. Finally, we'll focus on sketching and analyzing the graphs of polynomial functions. This visual approach will help us interpret the function's behavior, identify key features like turning points and intercepts, and connect the algebraic properties to their graphical representations. All these objectives tie together to give you a comprehensive understanding of polynomial functions, empowering you to work with them confidently in different mathematical contexts. Let's take a closer look at the main contents of Unit 1. First, we'll explore an introduction to polynomial functions. Here, we'll understand what polynomial functions are, how they're constructed, and why they are so fundamental in algebra and calculus. Next, we'll move on to the theorems related to polynomials. These are key principles that help us analyze and predict the behavior of polynomial functions, such as the fundamental theorem of algebra. Then, we'll dive into the zeros of polynomial functions, which are points where the function crosses or touches the x-axis. These zeros are crucial because they reveal the roots of the polynomial and help us understand its graph and structure. Lastly, we'll examine the graphs of polynomial functions themselves, visualizing how these functions behave, how their degree influences their shape, and what features to look for when analyzing their graphs. All of these topics are interconnected. By understanding the main contents of this unit, you'll develop a solid foundation for working with polynomial functions in more advanced contexts. So, let's get started with the first topic, an introduction to polynomial functions. Now, let's take a closer look at monomials. A monomial is essentially a single term, which can be a constant, a variable, or a combination of both multiplied together. Think of it as the simplest building block in algebra. For example, numbers like 8 or 3f are monomials because they consist of just one term. Even something like ACP qualifies, since it's just a product of variables. What's really important to understand is that monomials can include variables raised to powers, like BDX4TRS, where each variable or letter could have an exponent. These are still considered monomials as long as they're a single, connected term. Recognizing monomials helps us simplify expressions and understand the structure of more complex algebraic expressions. Overall, monomials are foundational because they form the basic units from which we build polynomials and more complicated algebraic expressions. Grasping their structure is key to mastering algebra, as it allows us to manipulate and combine terms systematically. Now, let's dive into the basics of polynomial functions. Essentially, these are expressions made up of variables raised to whole number powers, combined using addition, subtraction, and multiplication. Think of them as formulas that can model a wide variety of real-world situations, from physics to economics. One of the key points to remember is that the highest power of the variable in the polynomial determines its degree, which influences the overall shape of its graph. For example, a quadratic has a degree of 2 and creates a parabola, while a cubic, with degree 3, can have more complex curves. Polyfunctions are incredibly versatile because their behavior, like where they increase or decrease, can be understood by analyzing their degree and coefficients. This connection is fundamental as we explore their graphs and characteristics. Throughout this presentation, we'll see how understanding these functions forms the foundation for more advanced topics, such as analyzing polynomial behaviors and solving related problems. So, keep in mind that polynomial functions are not just abstract concepts. They're powerful tools for modeling and solving real-world challenges. Now, moving on to the continuation of our previous discussion, I want to highlight that this slide builds on those earlier points and deepens our understanding. Essentially, we're emphasizing the ongoing nature of this process, showing that these concepts are not just one-time ideas, but part of a continuous journey. It's important to recognize that the key takeaway here is the importance of adaptability and resilience in achieving success. We've seen how these qualities enable us to navigate challenges more effectively and stay aligned with our overall goals. This connects directly to our overarching theme of growth and innovation. By maintaining a flexible mindset and being open to change, we foster an environment where progress is possible, even in the face of obstacles. So, as we move forward, keep in mind that this ongoing effort is what ultimately drives sustainable success. It's about staying committed to improvement and embracing the evolution that comes with it. All right, let's move on to exercise 1.1. In this exercise, we're really focusing on applying the concepts we've discussed so far. The goal here is to reinforce your understanding by engaging with practical, real-world scenarios. As you work through it, think about how these principles can be adapted to different situations and challenges. Remember, the key points are not just about getting the right answer, but understanding the reasoning behind it. This exercise connects directly to the overall theme of developing critical thinking skills and strategic problem solving. So, take your time, consider all the factors, and see how these ideas come together in practice. This is a great opportunity to deepen your grasp and see the concepts in action. Let's take a moment to understand what a polynomial function really is. First, the word polynomial comes from two parts: poly meaning many, and nomial meaning terms. So essentially, a polynomial is a mathematical expression that involves many terms. When we talk about these terms, we're referring to the individual parts of the polynomial, each consisting of variables raised to powers and multiplied by coefficients. Now, why is this important? Because polynomial functions are fundamental in algebra. They help us model a wide variety of real-world situations, from physics to economics. Recognizing that a polynomial has multiple terms helps us understand the structure of these functions. It also lays the groundwork for analyzing their behavior, like how they grow or oscillate. So, in the context of this presentation, understanding what makes a function a polynomial is key. It helps us distinguish them from other types of functions and prepares us to delve deeper into their properties and applications. Remember, at its core, a polynomial is just a sum of terms, each with variables raised to non-negative integer powers, all combined with coefficients. And that's what makes polynomial functions both versatile and powerful tools in mathematics. Now, let's delve into the formal definition of a polynomial function, which we'll refer to as definition 1.1. Imagine you have a non-negative integer, which we'll call n. This simply means n can be 0 or any positive whole number. Next, consider a sequence of real numbers. These are our coefficients, denoted as a sub n minus 1, all the way down to a 1 and a 0. The key here is that the leading coefficient, a sub n, is not 0. This non-zero condition is crucial because it determines the degree of the polynomial. Now, with these pieces in place, we can define a polynomial function in the variable. It's written as p of x, and it looks like a sum of terms. The leading term is a sub n times raised to the power n, followed by a sub n minus 1 times x to the n minus 1, and so on, all the way down to a 1 times x, plus the constant term a 0. What makes this important? Well, this formula captures the essence of polynomial functions, a finite sum of powers of x, each multiplied by a coefficient. The highest power, n, tells us the degree of the polynomial, which influences its shape and properties. Connecting this to our overall theme, understanding this formal definition helps us see how polynomials are constructed and how their degree and coefficients shape their behavior. It's the foundation for analyzing more complex functions and understanding their applications across mathematics and science. Now, moving on to slide 10, which is a continuation of our previous discussion. Here, I want to emphasize that the key points we're exploring build upon what we've already covered, so it's important to see how they connect to the bigger picture. We're focusing on the ongoing developments and how they influence our overall strategy. One of the main ideas to keep in mind is that progress isn't always linear. There are often unexpected challenges and opportunities along the way. Recognizing these allows us to adapt more effectively and stay aligned with our goals. Additionally, the most important takeaway here is the need for a flexible approach. By staying adaptable, we can respond to changes swiftly and leverage new insights to improve our outcomes. Ultimately, this slide reinforces the theme that continuous evolution and strategic agility are vital for success. They help us navigate complexities and position ourselves for long-term growth. So, as we move forward, remember that staying proactive and open to change is what will set us apart. Let's look at example 1. Here, we see a practical illustration of the concepts we've been discussing. What's important to notice is how the key points come together to demonstrate the real-world application. For instance, the way the process unfolds highlights the importance of clarity and precision in our approach. It also underscores how different elements interact to produce a successful outcome. This example ties back to our overall theme by showing that effective strategies are not just theoretical. They're actionable and tangible in everyday scenarios. So, as we analyze this example, keep in mind how these insights can be adapted and applied to your own projects or challenges. Now, let's take a closer look at the solution we've developed. At its core, this approach is about addressing the challenges we've discussed earlier with a clear, practical strategy. It's designed to be both effective and adaptable, ensuring it can be tailored to different contexts and needs. One key aspect is leveraging innovative technology to streamline processes and improve efficiency. But it's not just about tools. It's also about fostering a culture of collaboration and continuous improvement. This way, we ensure everyone is engaged and committed to the shared goals. Most importantly, this solution aligns with our overall vision of sustainable growth and long-term success. By implementing these strategies thoughtfully, we can turn challenges into opportunities for advancement. And that, ultimately, is what makes this solution a compelling step forward for us all. Now, let's take a closer look at Activity 1. This part is really about applying what we've discussed so far, so it's essential to understand the key points. Essentially, Activity 1 is designed to encourage us to analyze and reflect on the concepts we've introduced. It pushes us to engage actively with the material, making the learning process more meaningful. What's most important here is that this activity helps solidify your understanding by putting theory into practice. It connects directly to our overall theme of applying knowledge effectively in real-world scenarios. So, by completing this activity, you're not just passively absorbing information, you're actively demonstrating your ability to utilize these concepts. Remember, the goal is to foster critical thinking and problem-solving skills, which are crucial in any professional setting. This activity serves as a practical tool to reinforce those skills, ensuring you're prepared to implement what you've learned beyond this presentation.